Hi guys, I'm going to go ahead and finish up the empirical rule notes here. The last three examples still follow the normal model, but we're going to have to calculate our z-score and then use the table or the calculator to calculate the probabilities because we're not going to be exactly 1, 2, or 3 standard deviations from the mean. So it will be slightly different. Okay, so let's go ahead and look at number 6. Entry to a certain university is determined by a national test. The scores on this test are normally distributed with a mean of 500 and a standard deviation of 100. Tom wants to be admitted to this university and knows he must score better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? The first thing I'm going to do is draw the normal model. Now, we know that the test has a mean of 500 and a standard deviation of 100. So if I go one standard deviation above the mean, that puts me at 600. We know that Tom took the test and scored 585, which happens to be just below one standard deviation above the mean. Because we are falling in between the mean and one standard deviation above, I know that we're not exactly 1, 2, or 3 standard deviations. So I'm going to have to calculate a z-score here. So my z-score is going to be 585 minus 500 divided by a standard deviation of 100 equals 0.85. Okay? Now, we want to know if Tom is going to get admitted to the university, and he has to score better than 70% of the students who took the test. So better than means that he's above, so we're looking for the area below. So we're looking for all of this area here. So I'm looking for the probability that his score is better than 70%. So the probability that X is less than 585. Now that probability has to be at least 70, otherwise he probably won't get in. So because I've calculated my z-score, X being less than 585 is the same as your z-score being less than 0.85. So I can use that, and I'm going to go ahead and use the table just because I have it right here. So 0.85, I go to 0.805, and I find where they overlap right here, and it's 0.8023. So then the probability that his score, or that somebody scores less than 585 is 0.8023 or 80.23%. Now that means that he scored better than 80.23% of all the other students. So then, yes, he will probably get into this university, at least based on his test score. For number 7, it says, the time taken to assemble a car in a certain plant is a random variable having a normal distribution with a mean of 20 hours and a standard deviation of 2. We want to find the probability that a car can be assembled at this plant for the following constraints. Again, I'm going to draw the normal model here, and I'm kind of doing it in between a little bit because we're going to do both A and B. So the mean is 20. One standard deviation below is 18. Now for part A, it says less than 19 and a half. 19 and a half is going to be right about here. So I'm looking for the area below that. And again, that's not exactly 1, 2, or 3 standard deviations from the mean. So I have to calculate my z-score, which is going to be 19.5 minus 20 divided by 2, which ends up equaling a negative 0.25. So I'm looking for the probability that we can get the car assembled in less than 19 and a half hours. So again, I can either use the calculator or the table. If I use the calculator, my lower bound would be negative 99. My upper bound would be negative 0.25. Okay, because that cutoff also gives me that z equals negative 0.25. And if I do that, I end up with a probability of 40.1%. So there's a 40.1% chance that they can get the car assembled in less than 19 and a half hours. For part B, it says the probability that it's between 18 and 22. So 22 I'm going above, so one standard deviation above is 22. So in this case, I actually do fall within 1 because 18 is one standard deviation below, 22 is one standard deviation above, and that's 68%. So the probability that you get the car assembled in between 18 and 22 hours is 68%. So in that case, we do still get to use the empirical rule, which again is nice because then we don't have to use the calculator or the table. Okay, last problem. Number 8 says the annual salaries of employees in a large company are approximately normally distributed with a mean of 50,000 and a standard deviation of 20,000. Again, I'm going to draw the model. The mean goes in the middle. I'm going to go ahead and call 50,000 just 50. So I'm going to put 50 in the middle. It just makes it easier for me to write. One standard deviation above would be 70,000. 2 would be 90, and 3 would be 110,000. One standard deviation below would be 30,000. 2 would be 10,000, and 3 would be negative 10. Now, it's impossible to have a salary of negative 10, so getting a z-score of being of negative 3, of 3 standard deviations below the mean, is not going to happen because it's impossible. And that happens sometimes, and it's okay. What we really want to know, though, is for part A, what percent of people earn less than 40,000? So I'm looking for the probability that X is less than 40,000. So I'm looking for, so 40,000 would be about right here. And so I'm looking for the area below that. So I have to calculate my z-score because, again, I'm not 1, 2, or 3 standard deviations from the mean. So my z-score would equal 40 minus 50 divided by 20, which gives me a negative 0.5. So again, if I use the calculator, my lower bound would be negative 99. My upper bound would be a negative 0.5. If I use the table, I use the negative 0.5. And that gives me the probability of 30.9%. For part B, it says what percent of people earn between 45 and 65? Okay, well, 45 is going to be about right here. 65 is going to be about right here. So I'm looking for the probability that somebody's going to make in between $45,000 and $65,000. So I actually have to calculate a z-score for both of them. So z is going to equal 45 minus 50 divided by 20, which is a negative 0.25, and z will equal 65 minus 50 divided by 20, and that ends up equaling 0.75. So if we calculate this on our calculator, my lower bound is negative 0.25 and my upper bound is 0.75. If we use the table, we have to look up both probabilities and then subtract them. And if we do that, we will end up with 37.2%. So there's a 37.2% chance that somebody will earn in between $45,000 and $65,000. The last one is C, which says what percent of people earn more than 70,000. So I'm looking for the probability that they make more than 70,000. Well, 70,000 is actually a 1 standard deviation above the mean. And I'm looking for the area above that. So I really can use the empirical rule here. You can still calculate your z-score. You'd end up with 70 minus 50 divided by 20, and we get 1. So because I'm exactly 1 standard deviation above the mean, I can use my empirical rule because I know that within 1 standard deviation is 68%. So then 100 minus 68 is 32. So there's 32% left over. Since 68 is in the middle, that 32 makes up the 2 areas on the outside, and each side is equal. So if I cut that in half, I get 16. So above, that would be 16%. So this equals 16%. Okay, that is it for the last 3 examples. Hopefully this makes sense. Again, if you have questions, please feel free to email or show up to one of the Google Meets. That would be awesome. All right, thanks guys. Have a good one.